And you can always, if you choose to, you can go on Microsoft Teams at night and watch the class. So
Okay. So I really didn't get the last few questions.
we'll talk about them.
12 through 17, because they just said to graph all the things. I tried.
Okay, that was the point of having graph paper.
Oh, you were supposed to graph them all.
Well, you didn't have to necessarily, but
well, they all overlap.
they would overlap, right, if you did them all in the same graph.
Yeah, so that's
Hello.
Good morning, men.
Good morning. I made a few mistakes that I caught.
Good afternoon. Sorry, yeah. What am I thinking?
I don't want to say morning. No.
Well, I actually did hear him this morning because he butted into his sister's class. And...
Bad.
All right. So, McKinley, what were your questions?
Oh, I get it now. I just did
Oh, you do?
weird math. Yeah, it's a weird calculating thing.
Anybody try to do it on your calculator?
Ooh, I could totally do that.
It's definitely, I would say none of this this particular thing would be easier done on the calculator.
No, it would not. But I'm gonna do
Now, on the online one, I'll show you here in a second how to do it the online one. It would be easier, but the graphing calculator, it's not as nice. No questions?
No. Is there a more powerful calculator that I can use besides a graphing calculator? Like one that's so powerful it can do everything?
Well, I'm going to claim that calculator there can do everything that we ever learned in high school.
Yeah.
In math, and science as well too.
Science. What about history? Can I take mine in history?
You can, because you can type in flashcards into it.
Oh.
So you could have, vocabulary words or whatever. All right. 1 through 17 all, and number 20. Number 1 is angle T. Number 2 is the measure of angle I. Make sure it has an M angle I. Number 3 is no line over the top of its CA. Number 4 is segment IG, so line over the top, line segment. Let's see, 5 is triangle ATC. And 6 is triangle BGI. Number 7, let's see, name 4 congruent angles, EFST. Number 8, that's definition of congruent triangles. All right, number 9, I'm not going to call it off. There's just too many of those. And plus, we did a bunch of those in class, and you guys did fine on that. Okay, I would say 10 and 11 were the hardest ones.
Really?
Right? Well, they were the more of straight up, this is geometry type stuff. So let's see, 10A is triangle KRO. If you wrote any 3 letters or not in that particular order, you're wrong. It's got to be KRO. I think they were trying to spell the word stork, but they didn't do a very good job of it. B is angle K and CPCTC. Why are they congruent? Because, well, the 2 triangles are congruent, therefore the corresponding parts are congruent. C is segment KO, and it's also because of CPCTC. And there's a third part there, then point O is the midpoint of SK. D is angle R because of CPCTC. They're parallel because alternate interior angles are congruent. 11 was kind of a repeat, just a different shape. Okay, see the triangle congruency, this is how it has to be written, RLA. That's 11A. B is segment RL. C is angle 3 because of CPCTC. Then PA is parallel to LR because alternate interior angles are congruent. We can kind of see how this is going. D2 is congruent to angle 4 because of CPCTC. Then, now you could have said this in a couple different ways. The book said PL is parallel to AR, but you could have put your letters in whatever order you want as long as it was P and an L and an A and an R. And the alternate interior angles are congruent. All right, 12. I'm looking, okay, here we go. Is 7, 2. 7, 2.
Okay, yeah.
13 is 7, -1. Let's see, 14 would be ABC is now, okay, so I'm going to call this out. Now you may not have written them in this order.
Mr. C, I did number 14 on my calculator.
What's the answer?
What do you mean? Okay, where's?
Give me the triangle congruency statement.
Oh goodness. Calculate.
You didn't label them on the calculator.
No,
ABC is congruent to FDE. So you may have written it differently, but A's got to go with F, B's got to go with D, and C's got to go with E. That's 14. 15. A's got to go with E, B's got to go with D, and C's got to go with F. Am I confusing you, or you understand?
No,
what
I
mean?
got it. I just
Okay.
really didn't read this all that well.
Well, this is why I wanted you to have graph paper. 16. A goes with F, B goes with E, and C goes with D. Now, I'm not calling out the actual answer. I just didn't want to say triangle ABC is congruent to triangle FED for number 16, because you may have chosen the letters in a different order. But the pairing that I gave you is the correct answer. And the last one, A goes with F, B goes with D, and C goes with E. Am I confusing anyone? Okay, good. And that was, number 20. Let's see. Nero Maro. What is Maro?
It's supposed to be like Roma.
Rome. Oh, God. Yeah, Nero and Rome. I do a poor job of that. Why don't they make that so it matches?
This is the best I could do for calculator, but it's long. It took so long.
This is why I'll just show you. If you're at home and you're next to a computer, right, this is probably a little bit easier.
Only 6 entries to do this.
It will, because you got to do 6 points, right?
Yeah, you got to do 6 points, and then you got to.
Where is the internet? There it is. Share. All right, so Ben, I'm showing you, trying to sell you Desmos, as I always do.
Okay.
You can only see this.
Why can't you see this?
Because I think you're still at 5 points.
Oh, yeah, duh. There we go. All right. Desmos, give me one of them, Jack.
Okay.
I'll show you how quickly this is done.
-1, 2.
So I can put A, -1, 2, enter. It doesn't like when you put an A there. I forgot. Okay, there's a point. Then if you put a label, then you can say A. There you go. See how quickly this is?
And then B is 4, 2.
4, 2.
And then C
That's
is
B. And C is
2,
2, 4. It's still a pain in the butt.
Yeah.
I would argue this is probably quicker than even graph paper. Go.
D is 5, -1.
That's E?
No, that's B. That's B.
Okay.
Doesn't really matter though.
Yeah.
But E is 6, 3.
And F is?
F is 10, -1.
All right. It probably looks like just a bunch of random dots on the paper. All right. Are we supposed to play connect the dots here?
I just love connecting the dots.
That's not what I got.
No, those are the numbers you called out.
Oh, sorry. I was looking at the wrong one. E is 7, 1. And then, yeah, that's right.
Okay.
That's what I got on my calculator.
Yeah, so E goes C, A with D.
Yeah. And I mean, it's pretty obvious when you look at it visually what goes with what.
I did it with lines.
You can this on Desmos here. It's been a while since I did it. You have to put a,
You have to put
you got to put a domain restriction on it. So you got to say something like, I forget how it's done, whether it's done with, I think it's done with this. And so you say, it goes from -1 is, oops, sorry, -1 is less than X is less than 5. Is that how it's done? Something like that? No. All right, never mind. Okay. Oh, no, you got to write the equation line. So this would be painful to play connect the dots. There's another popular free program, and you've seen me use it a couple times. It's called GeoGebra. The only issue is this one doesn't put it on, it doesn't put it on a coordinate plane, right? It can, you can have a coordinate plane appear behind it, but you can, you can easily make segments and that connect up to each other. And if you want to add, oh wait, there's a point on the middle of the line. I mean, it makes a really pretty drawing and whatnot. So I use this when I'm like making presentations. So your calculator actually does it easier than this one. Yeah. Okay. All right. No questions. Ben, you got any questions on the homework?
No.
Okay. They would think you were a god and they would burn you at the stake.
Why would they burn? No, they would not. That's Salem 1600. Yes, they would just worship you.
I forget which scientist said it. I want to say it's Stephen Hawking, but it could be wrong. But he basically said that, or maybe it was Richard Feynman. He basically said that any modern invention that we have, if you went back, 300 years, they would not be able to explain it. They would call it magic, and they would burn you at the stake. They would think you're a witch. I mean, just think about that calculator right there. If you went back, 300 years ago and you showed it to someone.
Well, that's all. But only 300 years ago. If you went back like a few thousand years ago, they would work.
They would if you went back to Salem in 1600, but they wouldn't if you went back to like ancient Egypt. They would just think you're a god of like a god of magic or something.
They might kill you because they're scared of you.
Well, they didn't kill the pharaohs. They thought they were all gods.
I don't know enough. I'm not an Egyptologist, but I would say it's probably because he had a whole government set up that protected him as well too. A whole system of I'm in charge, but I'll give you a little bit of power as well too. Therefore, you're loyal to me, and then therefore you're going to make the people underneath you think that I'm the god. And what's never been explained to me truly is that did the people truly believe? Was it like religion now, where it's an accepted internal belief in that particular type of thinking? Like, did they truly believe that he was a god, or did they just worship him as, well, you're in charge and you can get me killed at any moment, okay, you're a god, yep, I believe that? Or did they really truly believe that? That's what's never been explained to me. I need to do more research on it. All right, that is not the calendar. I did not change it correctly, so let me get the right calendar.
Wait, so we're changing?
We're changing, and it's for the better. Calendar, I thought I changed that calendar last night when I did this. Yes, there's the calendar, except for the wrong one, so copy. That there. All right, so this is the actual calendar. So this one is really important. So what I did was basically just break it up in 2 days. Today will be the class, tomorrow will be practice. And we'll go from there.
Why do you have to go to school?
Columbus Day.
Oh, nice. Oh, nice. I get to sleep in for 15 more minutes. Wait, oh, okay. Yeah, I don't sleep in that long.
Well, 15 minutes, still 15 minutes, right?
Sleep in for like 6 more hours.
Yeah, that's sleeping in.
No, I probably sleep in for 4 more hours, maybe 5.
But you waste half the day, especially.
All right, there's your homework.
I don't like wasting my weekend. So I try to get up as early as possible.
Wait, what about homework correction?
We just did it.
Really?
While you were trying to
I must
figure out your
I was thinking my
What did you think? I was just up here talking or way? Or
Sorry.
we literally went through the entire homework, Jack.
Well, I was grabbing on my calculator.
Oh, I know. Jace did have some problems on a homework a few nights.
Did you help him?
No, I was watching TV.
Who helped him?
My mom and dad.
Are they good at math?
I think my dad is.
What's he do?
He's moving into some sort of space work.
Oh, is it Air Force or civilian
He's
or
in
what?
Air Force, SpaceX. I don't know. He's moving jobs today, so I don't know what he's doing exactly.
Cool. Is that something you're interested in doing?
No.
No.
I don't like space all that much.
Have you figured out what you want to do yet?
Yes.
What?
Historian teacher.
Oh, that's right. You told me that yesterday too. Yeah, that's cool. Cool. The nice thing about that is, unlike if you want to, mess around with rockets, you just can't go to any school to do that. You want to go to a special school, that not every school has a rocket science, major, and probably none of them do, but they have aerospace engineering, would probably be the closest to that. And you have to go to, college that offers that. But if you want to be a history major, you can go to pretty much any college. They always offer history. So, but you want to go to a good one, obviously. Okay, yeah, so I built this up saying that this one's important. It's because of this right here. Proving triangles are congruent.
You already know they're congruent. If I just put in a line.
No, we're starting the fact that they may or may not be congruent. You're proving that. And the reason why this one's important is because we can take any polygon, make a diagonal, or diagonals plural, and make a bunch of triangles. So if you want to show that one shape is like another shape, well, make it into triangles, but then you got to prove the triangles are congruent. And that's why this one is important. All right, so last class we got this right here. You don't need to write this down. This is already your book of truth. And it says polygons, not just triangles, are congruent if and only if the vertices are matched up in such a way that all the corresponding parts of shape number 1 are the same as shape number 2. And this is an if and only if statement, so it's biconditional and it goes both directions. So if the polygons are congruent, then all their corresponding parts are congruent, or backwards way. If the corresponding parts are congruent, then you conclude that the polygons are congruent. And this one in green, we will use the one in blue a little bit, but the one in green is what you basically spend the rest of the book doing, right? For today, this chapter, and heck, the rest of the book, that's what you'll be doing. I'm going to give you a triangle. I'm going to give you another one. And you're going to prove that the two are congruent. Okay? Now, as the book progresses, we'll be doing different things if they are congruent, but this will be part of nearly everything that we do. Hey, start off by showing the two triangles are congruent. All right, there are, well, today, by the end of the class, you're going to know 4 methods, right? I'm going to call this method number 1. It's not even mentioned in the book, by the way. But this is method number 1. Well, based upon that previous definition, how do you show that two triangles are congruent?
By looking at their sides
And
figure if they're equal to each other.
And one more thing you got to do. We look at their sides. How many sides does a triangle have?
Look at their corresponding parts of their angle.
Well, what are the other corresponding parts? Their angles. So then we got to look at their 3 angles. So you got to look at, on the other hand, 6 things in order to prove. This is called method number 1. It doesn't really have a name. But to show that two triangles are congruent, right? Show that this blue one is the same as the green one. Well, then you got to show that all the corresponding parts are congruent. So I got to show that this side matches up with one of the sides over here, and the second side with one of these, and the third side, and then do the same thing with the 3 angles. So 6 things. It's a lot of work. So you need to show that the 3 angles are congruent to the 3 angles of the second one, and you need to show that the 3 sides of one triangle are congruent to the 3 sides of the other. There is easier ways, and that's what the rest of this chapter is about, right? Because that's 6 things that you got to do. Oh, by the way, if it was a pentagon, you know, then you got to do, let's see, 3 times 5, 15 times 2, 30 things, right?
What, is that from King Kong?
No, I just put thinking gorilla in the Google and say click pictures, and that was the first thing that popped up. All right, not that you're gorillas. All right, think about this. I'm going to give you a triangle, and I'm going to draw another one next to it that has the same characteristics. All right, so I'm just going to start at any side. I'll just start with AC. So my second one is going to have the same length here. Does this say anything about the angles?
Yeah.
So I can draw it any way I want. So I'm going to choose that this one is this long right here, right? That side. I'm going to choose to draw it like this. So I'm going to draw it like that. Okay. If I connect that side to that side, will it be this long?
No, it won't.
Yes. Yes. No.
Wait, no, you know, what?
No, it won't be long. It will be just.
Will it be the same or will it be different? How about that?
Different.
Be different. Okay, so that didn't work. If I draw it this angle smaller, right, and I make it the same length, and then I play connect dot, will it be this long? Right. So if I have those 3 distances, that one, the one with 1 tick mark, right, and the one with, I leave off 2 tick mark, that's the longest one. If I have those 3 segments and I make that into a triangle, will it look the same or different as that one? Will look the same. So this is not necessarily a proof because it's a postulate, right? So if I make a different triangle that has all sides the same as the previous one, those 2 triangles have to be congruent. I didn't say anything about the angles in this proof right here? Did I say anything about any one of these 3 angles other than consider this? I didn't. So this only involves the side. This is called?
Sides of a triangle postulate.
That's what it's called. except they call it SSS, right? Because remember, it can also apply to triangles instead of using course or congruency symbols. It can also apply if there were measurements. So here's what it says. It says that 3 sides of a triangle are congruent to 3 sides of another triangle, and the two triangles must be congruent. So instead of having to show 6 things are congruent, I only need to show 3. So we saved ourselves half of the work. So this is called just simply SSS. When you're doing a proof, you simply write SSS and you're done. Why are those 2 triangles congruent? 2 on the left, SSS. Why are those 2 triangles congruent on the right? SSS. They also can combine these 2 concepts. They may have congruency tick marks, and they may have numbers. Regardless, they're showing that 3 sides of one triangle are congruent to 3 sides of the other. If you can get that far, then you know that 2 triangles are congruent. I don't know if you remember, but we did do this in pre-algebra. This one right here. We did it one day. Now you're going to have the rest of the course on this stuff.
I figured out something. Turns out you can draw triangles inside a circle.
You can, and we will do that this year. It is called an inscribed or a circumscribed triangle.
But you said we couldn't draw a triangle.
You can't
Oh, I can't cut a circle up into triangles.
Well, I mean,
You can.
And then
The
I'm taking,
triangles just have to
yeah,
be
but am I
congruent.
going to cover the entire inside of the circle with triangles?
Yeah,
Yes.
triangles just have to be molecular.
That is called an approximation.
But no, you can. You can draw them all in.
Oh, by the way, we will do this, and we will. You can draw a. You're gonna when we get the construction. I'm gonna blow your mind with a couple things we can do with that. This is crazy stuff. All right, so SSS. Just so you know, if we do have an SSS postulate, we don't have an AAA postulate. You want to know why? Well, what would AAA mean?
A AAA battery.
Okay,
Advance,
yeah.
advance.
What would the A mean?
The angles.
So why isn't it true? Why is it true for sides, but it's not true for angles?
Because you could have a tiny one that has all of the angles, but a big one that has all the same angles.
See what I mean?
Well,
So here's 2 equiangular triangles, right? They all have the same angles, and they're all 60. So clearly those 2 triangles are not congruent. We have another word for them. Those are similar triangles, and we'll spend some time. Some of the hardest formulas we'll have this year are about similar triangles. Okay, so remember our goal is I need to show that the blue one is congruent to the green one. Now we have, well, 2 techniques. We got the method number 1 nobody uses. Method number 2, or the shortcut, is SSS. But what happens if we can't show that 3 sides are congruent to the other 3 sides? We've got some other shortcuts, right? Before we do that, though, I've got to do some definitions first. We've got to do some definitions. This doesn't need to go into your book of truth, but write it somewhere. All right, so these are weird, right? I didn't hand out the sheets today. I'm like, well, just write this one down, and I didn't hand the sheets out. All right. Resist the urge to do the proof first. All right. So the first one is this. Look at the board. So I got a triangle. I've only got 2 of the vertices labeled, A and B, and I've got this angle right here. I don't know how big it is. I'll just call it C.
Oh, I know.
That's
what
my
you're
variable.
gonna do.
Well, what am I going to say?
You're going to say that if line AB is congruent to another line and C is congruent to another angle, then they're congruent.
No.
Why not?
What I'm going to say is I'm going to give a name to the side that is opposite angle C.
B,
What do you want to call the side that is opposite angle C?
C.
No, that's for right triangle. Well, we certainly could call it AB, right? Well, what if you didn't know this was A or B? What would you call that side?
Make it up. 3.
Opposite side.
Write that down. Now, the reason why I'm going to give you these definitions is because the other 3, we only learned 2 of them today. The other 3 shortcut methods are going to use this word opposite side. So you got to know, make sure you know what opposite side means. Now, we run into a problem with shapes larger than quadrilaterals if we use the word opposite. I draw a pentagon. Well, which angle is opposite, or which side is opposite of an angle? You got 3 choices. So that's why we don't use it, but it certainly works well. It'll work well also in a quadrilateral. You just got to make one little extra addition to it. But opposite side for a triangle makes sense. Hey, it's the side that's opposite the angle. Okay. Well, if we have an opposite side, we must have an opposite. Well, what would be the opposite angle? No, what would it look like an opposite angle? What would be the setup for an opposite angle?
The same.
Literally the same?
Well, yeah, because C is opposite to AB.
What would change in the diagram?
Well, you would twist the arrow around.
Okay, so do that, please. So the side that is opposite, the angle that is opposite side AB, we call the opposite angle. So far, so good. The first two definitions are easy. Everyone can come up with the first two. Or at least I should say everyone should be able to come up with the first two. And the names are very intuitive, right? The next two, they're not very intuitive.
Are you gonna give our test back?
Yeah, I'll give you back.
I still haven't taken it yet, though.
What? You got to take it today then. Why didn't I give it to you yesterday? I don't remember. Why didn't I give it to you yesterday? I don't know. You did not take your test? Okay. Interesting. Okay, moving on. Okay, so the next two are not intuitive, and the names aren't descriptive. So here's the picture. Do you see angle C? There's two sides next to angle C. What are the two sides?
CA and CB.
And I'll just make them red. We have a name for this relationship when there is an angle between two sides.
Adjacent sides.
Shouldn't it be called the,
Adjacent sides.
no, the angle?
The angle should be the.
How would you describe the angle in relationship to the two sides?
The vertex.
Don't overthink this. You're visually just looking at it. How would you describe the angle?
The angle between two sides.
Shouldn't it be called the,
Angle between two sides.
or maybe the between angle? Wouldn't that make sense?
Yeah.
They don't call it that. They call it the included angle. But it's the between angle if you want to put a Mr. C name to it. It's the angle that's between the two sides.
So technically, isn't every angle included angle? Because that's have two sides.
Yes.
Like,
Or I should say every angle is an included angle on a polygon.
So
Correct.
nucleus is wrong. Euclid is wrong.
This is probably Euclid that came up with that word. I don't know. Maybe. All right. So that's called the included angle. It would lend you to believe that there's something called an excluded angle. Okay. Well, that's the two that you're not using. We don't go that far, but we do have the opposite of this. What would be the opposite of this?
the excluded.
Well, instead of the angle between the two sides,
The side between two angles.
so what would the side between two angles be called?
The included side.
Okay, now, so that's your next one. So the included side would be a side between two angles. Notice both angles must touch that side. Just like on the included angle, that angle must make. In fact, that angle is formed for an included angle. It's formed by those two sides. So the included side is the side that's between the two angles. Lost? We lost? Like, just some weird definitions, right? Okay, so quick review. This is called the
Opposite angle, opposite side.
this is called the
Opposite angle.
this is called the
Included angle.
and this one's called the
Included side.
okay. So we're going to use these. Remember, the big picture here is we're trying to prove that this triangle is congruent to this one. We have two methods, but we really only have one method because nobody wants to use method number one. It takes too many steps. So no, thank you. I'm going to use side, 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 or any of the other 3 or 4 shortcuts. I've taught you this one. There are more. All right, so here comes the next one. So you got to imagine this, right? You see that triangle?
Yep.
Okay, so let's try to make another one, and we'll see if it's like it or not like it. So I'm only given three things. I'm given two sides and an angle, right?
SSA.
So let's see. Well, I got to make AB exactly, and I got to make AC exactly. Why? Because this angle is right like that. You see it? Is there any way to connect? And I can't move it, right? I can't make the angle bigger or not because it says it's got to be that big. Is there any way to connect the two endpoints now to where it wouldn't be that long? Yes, no? And the reason why is because I'm not allowed to move. If I move this, then it's no longer congruent, right? So that's the logic, and this is called, take a guess.
SSA postulate.
Well, if we read it from right to left or left to right, it would go S or SA, and it's the same thing. So this is called, and the logic is this right here, is that if this is the setup, you have a side and angle on the side, there's no way to connect G to H without having it be exactly the same length as B to C. So this is called the SAS postulate. Now, they're going to use words that we just use for our definition. It's going to say if two sides and the included angle are congruent to two sides and the included angle of the second triangle, then the two triangles are congruent. So this one I didn't need to talk about three sides, but I did need two of the sides, and I specifically needed the included angle. So now we got two tricks or shortcuts, SSS and SAS. Technically we have three.
So then we could do two angles at a side.
Let's see.
No, you couldn't do that.
Well, we're about to find out.
No, you can't do that.
We're about to investigate it.
Excuse me,
Yes, ma'am.
can I have McKinley for dismissal?
He's on his way.
That's my cute. Gotta go.
Is this orthodontist or no?
Yes.
Okay. Hey, we'll pick this up tomorrow, and luckily for you, we're doing a review tomorrow.
Okay, I know.
All right. So here's an example. Now, visually, you might be able to convince yourself.
Should I still do my homework?
Yes.
Okay.
Read for, there's only one I didn't cover. As you look at these two, maybe you can convince yourself in your mind that they're congruent, but maybe you can't. But notice I've got a side, an angle, and a side. I have 369. And this one also goes 369, side, angle, side. Therefore, that's all the information you need to convince yourself that those two triangles are congruent. Tonight for homework, they're going to say, are the two triangles congruent and why? So the why is, we're just literally going to say SAS. Okay, why? Because of SAS. Then they're going to ask you to write a congruency statement. That's going to be the more challenging thing. All right, who wants it? Give me the congruency statement.
Okay. ELM is congruent to YOD.
Okay, so once you pick that path, he went ELM is what you said?
ELM.
ELM, right? So you went 9, unknown angle, right? So if I start off with,
No, wait, it's YDO is what it is.
so if I start off with the Y, with the unknown, I'm sorry, he started with,
No, it's DYO.
You started
It's
off with-
DYO. It's DYO.
well, I'm going with what you first said.
No, it's DYO. It's DYO. I was wrong 2
All right.
times.
So if he starts off with the E, right, which is next to the 60, well, then we got to start off with D, and then he went to unknown angle. Well, here's an unknown angle, right?
He's going with
But that's going on the 3. We don't want to go to the 3. We want to go down the 9 side and then go back. So DYO is what you gave me? Okay. Let's see what the book said. No, they chose different letters, but same idea. Okay. Just spend some time on those congruency statements and convince yourself that you did match them up. Maybe not redraw the triangle, but some you might want to. There's one more that we'll do today. There are more than this.
I knew it.
Well, I haven't proven it yet. Oh, by the way, it's postulate. Okay, so let's think this through. what are we given right here? We got two angles and the, which side? The included side, right? So I got two angles and the included side. So let me see if I can draw that. So I got two angles, all right, that one's congruent, and the included side. Notice I drew this much shorter than what it actually is. You tell me, is there any way that if I actually extend those, that they meet at a different location than what's shown right there? Like if I were to extend this one right here, is there any way that when this connects to that, it's not that length? Well, there is a way, but the only way you make that happen is if you move this, right? Now it connects up here, now it connects down there. Then you're changing this angle and it's no longer ASA. So the answer here is that yes, ASA is the other one. But as we stated with SAS, you need to make sure that you understand fully that it's the two angles and the included side. So this is ASA. There's two others that we will get. We just won't get them right now. Some books will immediately give you all of these up front. Our book chooses to give you a bite of this. And we'll take the full bite later on, or the second bite of this later on. The only problem that is some of the triangles they're going to give us tonight are actually congruent. We just don't have the shortcut methods yet, the other shortcut methods. All right, so this is your ASA. Remember, it's the two angles and the included side. It doesn't have to be the bottom one, by the way. It could have been, you know, the top vertex, the right vertex, and the included side. So two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, and the two triangles are congruent. ASA. Got it? And by the way, you're going to have these so memorized after tomorrow that you're not going to flip through your book to figure this one out. You're just going to, oh, that's SSS, that's ASA, that's SAS. All right, so here's an ASA example. Check it out. I got 90 degrees, a 4, and a 55. If this one has a 90 degrees, a 4, and a 5, and they're next to each other, right? It has to go ASA. You know, if this is your 55, and this is not here, well, then this is actually angle, side, right? Instead of ASA, although it's ASA on this one it's AAS.
But that would be right, though.
We will see. We will see.
But is there a way to do that?
What do you mean?
But that's right. You can do AAS.
We haven't proven it yet. And we'll talk about it later. All right, so, oh, I forgot to give you a triangle congruence. That one's a little bit easier because everything's right next to each other. All right, so where are we at? To prove two triangles are congruent, to prove the blue is congruent to the green, we got those three options right there. What don't we have? I already showed you one of the things we don't have. What don't we have? What letters appear there that we don't have? We don't have an AAA. We also don't have yet.
An AAS.
We don't have an AAA. We don't have an AAS. We'll talk about that later.
An SAA.
We don't have an SSA, right? So I'll table this one for a later conversation, right? But I will explain why you don't have this one, right? Clearly this says what? This says SSA, right? So can I make a triangle that has 6, 11, and an angle 30 and appear exactly like that? And the answer is, heck yes, you can. But there's a problem. And the problem is where this blue X mark is. Okay? Here's the problem right here, is because this triangle, because you're not telling me how big this angle is where the X is, gives me two options. Well, clearly I could attach right here, right? I'm sorry, right here. But it also could attach right here. It intersects that dotted line right there in two different places.
So it's a parabola.
Well, there's a parabola here, but I'm saying, or a circle actually, not a parabola. But the problem is that it doesn't define a single triangle. This notation right here defines two different triangles. So even though, yeah, we could make one that's like that, we also could make one that's not like that one if we connect it here instead. Okay? So this is your classic, I don't have an ASS, right? I have no idea why they sound like that, but apparently donkeys sound like that. All right, some math books literally call it the donkey postulate. There is no donkey postulate. They're just saying it doesn't exist, right? Okay, so you also don't have the AAA. All right, so those are the three so far that we have. So tonight for homework, they're going to ask you to prove things. So let's prove one. All right, I'm going to try to prove that the triangle on the left is the same as the triangle on the right.
Well, we know TE is the same.
So Anna, what's our given information?
But E is the midpoint of segment MJ.
So what's the consequence of E being the midpoint of MJ? What's the consequence? If you're a midpoint, let her answer. Let her answer. If you're a midpoint, then what?
Then both sides are equal.
Yep, so that means they're congruent. So I could put a tick mark right there. They're congruent. Hey, we've got a side. What's the next statement? What didn't we use so far in the given?
TE is
So what? What is that going to give us?
the two triangles with me.
No. What does that statement, TE is perpendicular to MJ, give us? What does it mean to be perpendicular?
That they create 90
Where are the 90-degree angles?
TEJ and TEM.
So now I got a side. I got an angle. Finish it.
And then you got TE.
Now you got to pay attention to this one. Do you remember when we wrote properties that I said, just write this down. I'll tell you when it's important. Today's it's important and going forward. How many do the triangles have separate third sides, or they have one side that they share? This is the reflexive property. TE is congruent to TE. Therefore, you get that, and therefore now we have an S, an A, and an S, and that's the whole darn proof, right? So to prove that, it doesn't matter how you start. So I'll start with the fact that this was Anna's statement. That's by the definition of midpoints. That means that they're equal, they're congruent. Perpendicular lines tell me that there's 90 degrees angles. Well, if they have the same measure, that means that they're congruent. That's the definition of congruence. And lastly, the reflexive property. You're going to use this over and over, reflexive property, right? TE is congruent to TE. You're like, that's the dumbest thing I've ever heard in my life. TE is congruent to TE. Well, duh, right? But that's where we get the last S of our SAS. So you do have to make that statement that something is reflexive. Because if you're going to claim that the reason why the two triangles are congruent is because of SAS, you better give me all three letters. And I did. Here is letter number 1. There's your S. Here is letter number 2. There's your A. And here's letter number 3. There's your S. SAS. That make sense? That's pretty easy proof, too, once you see it, how it's done. Dan, you got this?
Yes.
Okay, QED. I'm going to show you a couple things that look like for homework. Read, Jack.
Does the SAS postulate justify that the two triangles are congruent?
So it's saying you can only use SAS. You don't get the other two. So is that SAS?
Yes.
Okay, so when you do that, to answer this question, you got to look at the first one. Does the first one say, does it say SAS?
Yes.
Don't assume because the first one says SAS, the second one says SAS, right? The first one says SAS, the second one says, oh, it says yes, so that one's good. So that one's a yes, right? Or not SAS, but a yes. Anna, does this say SAS on both of them?
Yes.
No, so that's an SAS. What does this one say? SSA, so no. Nope. Okay. So yeah, that one is your standard ASS. Right. Okay, so now who we on? Jack, read.
Can the two triangles be proved congruent? If so, what
All
postulate?
right, so we got the three options: SSS, SAS, or ASA. All right. It's not. That would be to show. That's what we're going to do the day after tomorrow, right? So you just tell me: are these two triangles congruent? If so, which one of the three?
That's ASA.
Is it on both triangles?
Yes.
Okay, so that one's ASA. Anna?
Just S.
Yeah, there's only two letters there. There's two S's.
No. Adjacent side.
We wouldn't call it adjacent. We would call it a shared side. Therefore, if they share a side, it's reflexive. Therefore, you have 1, 2, 3. Now what do you have? I got an SSS. Okay. We're going to use that so many times that, in a day or two, you won't even think this through. You're like, oh, yeah, flexive. All right. This is a hard one. You want to argue?
Yeah, I want to argue.
Go.
Because of the vertical angle, because vertical angles, they're both.
Vertical angles are congruent,
so you get
therefore
SAS.
it's SAS. All right, be careful. Go.
But that's ASS.
It's what?
ASS, so it's wrong.
And yes, I'm going to have that sound every time it. All right. This one's clearly SAS. Read.
No.
Yes. This is the bad one right here. They will cause you problems because I'm going to give you 20 of these tomorrow to do on a worksheet, right? And you're going to be like, oh, look, SAS, but you won't look at the second triangle. Make sure you look at the second triangle. Which one?
The first one was
Well, I see an SAS because of reflexive, but the next one is. All right, that was enough of that. Okay, good? All right, that's it. Ben, questions?
No.
You like my donkey?
Not really.
Annoying.
What's Ben?
Do you want
I saw it all. I'm good. Don't get lazy on your homework. You're an honors class, but
I
don't
won't. And I'll send you my other homework as soon as I can.
All right. See you later, Ben.
Goodbye.